So the first time around when we ran this application, we get these two results, right? And I can basically keep this as just information to myself right now. And so the second time I run this, okay, so you can observe that the values seem to be, the values are the same because I'm printing owner 1 and owner 2. I need to stretch that, right, and run it again. And so these values are now different, okay? And so these values I actually can update now. Let me just use multi-line comment to keep track of these. So the second time when I run this, you can see that we'll just check if they're exactly the same or not. Right, so we compare them. They seem to be pretty much the same values. However, we'll see if I exit this environment entirely, right, close my project and get out of there, and then go back to my NetBeans to restart it, right, just restart it and go back to this project. Let's see that the next time I run this application, after restarting the entire environment, well, they're very close, but they're different now, right? So this time the values have changed. So you can see that. Oh, have they? No, they really haven't changed because apparently my Java virtual machine is still running. So it's it's just giving me the same values. But nevertheless, the hash code, actually, the hash code of your object guarantees that for as long as this object and this object exist in memory, this number will not change. And that means that each object does have in Java, when you create it, right? When you create it and your object exists here, it has this unique value which you can ask the object and it will provide you the value, and this is your object dot hash code, right? So this method hash code returns back an integer, right? So this is actually an integer value that comes back from this method hash code, and it provides you with unique identity, unique value for every instance. So although I created the property owner here and the property owner over there, and I can have actually another method, right? So I could say void print name, right? Print name over here, and make this also a static method, because I will be calling it from main, which is also static, right? And it will take a parameter property owner, right? Property owner, owner, something like that, and in this, and this may be also a public method if I'd like to use it externally. So something like this I can do over here, and of course change this to an owner, right? And instead of doing this directly, basically say print name instead of all of this in main. I can just say print name and pass owner 1 the first time, right? And the second time I can say print owner 2, right? So this is the demonstration of the fact that over here owner 1 is called owner 1 and owner 2 is owner 2, but over here it just becomes a variable named owner. It doesn't change the fact that I have two objects, right? And both of them have unique place in memory, and they do not move around. They stay where they are, and of course I need to change this over here as well, right? But nevertheless, the hash code, of course, if I run this, Okay, so the hash codes will be specific to each object, and they will remain stable for the duration of the life cycle of each object. So these are good examples. This hash code is actually a very good example of object identity in Java. Okay, we all should basically kind of know that the important thing is that object really once created, once instantiated. So if this is an array of memory, right, and I create new object, and I say new object property owner or something like that, owner, and it takes some parameters, right? So when the object is created, it's saved somewhere in memory, and it always allocates contingent memory. It never has any kind of gaps, and it is giving some initial address like x, 0, 1, 2, 3, B7 or something, if we want to use a hexadecimal number to describe this specific address. So this address will continue to be stable. This address is not going to change, and the object is not going to relocate itself at all. So that's why in Java world, right? So in Java world, what happens is that you get a reference to this object, which simply internally stores this address, right? And so this this reference variable can be named reference1, and you can pass it to another part of the program. Over here, it could be called reference2, but it doesn't change the fact that it's still pointing to the same place in memory and therefore refers to the same object. Of course, in C++ and C and C++, when you have structures and classes, what happens is that you can basically ask your object what is your address, and for that, if your object name is X, right, you can simply use ampersand, and the ampersand operator is the address of operator, and address of operator simply returns this address back, right? So it returns the type, essentially the pointer type to which will contain the address of that object and will specify where that object is. So at runtime, these types of things are useful in terms of determining object identity. And why would you want at runtime some sort of object identity? Well, sometimes you want to populate a structure such as this. Okay, so maybe you want to organize your objects, and I'm thinking specifically about Java situation. You can have an object which may have references to other objects of the same type, okay? And so these two may be referencing objects, again, of the same type, like this. And so, therefore, you can build trees out of these objects, right? So this looks like a tree because I can keep expanding my tree and adding more objects to it, right? So I can organize my object as a tree. So this would be some sort of a root node that gives me access to the entire tree, and I can basically jump around and navigate deeper to different levels inside this tree to go and visit these objects in a tree. But at the same time, perhaps I also would like to have a sequential access to these objects. And so, therefore, just storing references to these objects inside the actual class may not be enough. Maybe I also would like to keep a hash map, right? A hash map, which basically says that, I have object number 1, number 2, number 3, number 4, number 5, and so forth. in this hash map. And what I would like to do is that I would like to be able to populate the keys of this hash map with some unique identities, right? Which essentially connect me through stored addresses with actual objects. And so I simply need these, unique codes that I need to populate this. And in that sense, in Java, using the hashcode method of the object class in Java is very useful. This can give you a very stable value to populate your hash maps and other containers, which are basically associative containers which use keys to access other objects. And you can use these hash codes. So if you just simply need to generate unique identities for your objects because you want to construct something as complex as this, you can have a hash map that does that. And conversely, you can, instead of storing references to objects to build your tree, you can actually use hash values and find the actual objects through the hash map. So this can be a very useful technique overall, right? So because this gives you a lot of freedom in terms of how you can link between different instances of your objects, depending on the complexity of the data structures that you're looking for. And so we will be moving to our second room right now, but I will also, of course, talk about other types of identity compared to the hash code in Java.